Hi there everyone. In this video, we'll start naming simple alkanes, alkenes, and alkynes. There's no need for you guys to write in this little table here because it is actually found in one of your resource packages, your notes package, okay? But what I do want to point out is this table here gives you a list of what we call prefixes and suffixes for naming hydrocarbons. These prefixes and suffixes can be used for both aliphatic hydrocarbons, which means hydrocarbons that appear as a straight chain, or branching hydrocarbons, okay? Hydrocarbons that basically branch off of a longer chain. So we'll kind of distinguish the two throughout the next couple of videos, but for now, I want to look at how we actually use these prefixes and suffixes to name hydrocarbons. So the simplest hydrocarbon, of course, was CH4, a single carbon atom with 4 hydrogens. So if we look at the table here, if we have a hydrocarbon that contains only one carbon, okay, so a one carbon chain, we have to use the prefix meth. So prefix means beginning. So the name begins with meth, and to figure out the ending, the suffix, we have to see whether this hydrocarbon is considered an alkane, an alkene, or an alkyne. Okay? To do that, we look at the bonds that are associated with the carbon. Since the carbon contains all single bonds, then it is an alkane. Okay? So most of the time, if you have more complicated hydrocarbons, you will likely have more than just one carbon by itself. So if you have, for example, 2 carbons, but there's only a single bond in between them, that is a clear sign that it's an alkane. Okay, so the ending is always ane for alkanes. Now, if you have carbons that show a double bond, then it's an alkene. And if you have carbons or hydrocarbons that show triple bonds in between 2 carbons, then it's an alkyne. So the ending is going to change depending on the presence of a single bond, a double bond, or a triple bond between your carbons. So this list here gives us all the prefixes that we have for our hydrocarbon. So if we have a hydrocarbon that has a 2 carbon chain, the prefix is eth. If there's 3 carbons, it's prop. If there's 4 carbons, this is pronounced but, not but. But. Okay? 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and of course 10 is dec. So eventually you'll become very familiar with these words, but for now, if you have to refer to this table, of course, it's there for you to do that. So let's look at an example. Here we have a hydrocarbon, okay, that is a straight chain hydrocarbon with no branching groups. Okay, so what we need to do first is we have to identify the longest parent chain, meaning we want to figure out the longest carbon to carbon chain that exists in the hydrocarbon. So in this case here, I can see that there's 1 carbon, 2 carbon, 3 carbons, 4, and 5 carbons, and they're all connected together by a bond. So that makes this the parent chain. Now, we don't really care too much about the hydrogens, okay? The hydrogens are not really a part of the name, okay? But this particular hydrocarbon, because there are 5 carbons, 5 carbons has the prefix pent. So the name of the parent chain begins with pent, and because you have single bonds all the way through, Okay, so they're all single bonds. This will now become pentane. So the suffix is ane, the prefix is pent. Put them together, and that's the name of your parent chain. Okay. For all straight chain hydrocarbons, this is the easiest type of hydrocarbon to name, because once you've named the parent chain, then you are done. Okay. So this is called a an expanded structural formula. Because it's expanded because you can see all the bonds and how they all attach to every atom. Most chemists can be lazy sometimes, so it's understandable that we don't always want to draw out each and every single bond. So in the second example here, I have something called a condensed structural formula. Oops. Now, often I will just refer to it as a condensed formula, but the reason why it's condensed is because if you look at the two ends, okay, you have one carbon here, the one that I labeled number 1, and I have one carbon over here. There's 3 hydrogens surrounding the carbon. So instead of drawing all the bonds, I collapse it. Okay, I take away the bonds and I just collapse it and condense it so that it's now called CH3. Okay, so this CH3 represents this one carbon with 3 hydrogens. So the bond in between is still a single bond. Okay, and it's still a bond. It's understood that even though the H is in the way, it's still understood that this carbon is attached to this carbon. Okay, so the first carbon is attached to the second carbon, attached to the third, attached to the fourth, attached to the fifth. So again, there are 5 carbons. So the prefix is pent. And every single bond is a single bond, so it's pentane again. It's just in a different form. If we look at the third one, this is an example of a chemist being even more lazy. This is called, well, I call it a zigzag formula. Most people sometimes call it a stick formula. I don't like using this one because it's easy for new students, new organic students, organic chem students to make mistakes. But once you use it often enough and you know where to avoid these mistakes, okay, it's actually pretty handy, okay, especially if you're drawing something that is very, very large. But in this case here, you have a zigzag line. And if you understand what the zigzag line means, okay, I'm sure that you guys will be using it properly. Now, if I put a dot at the beginning and at each corner, these dots represent carbons. Okay. Now, because we want to shorten the actual drawing, okay, we've taken out the hydrogens. So it's understood that even though there's a carbon here, it does contain their hydrogens. But we don't really care exactly the specific number of hydrogens. Okay, that's not the point when you're drawing a zigzag formula. So if we have 5 dots, that's 5 carbons. Okay, we make it a zigzag because a straight line won't be able to show these carbons and hydrogens. Okay, so that's why it's zigzagging. This was also a pent because it's 5 carbons, and every line in between the dots represents a single bond. And therefore, you have pentane. Okay. What's neat about this is we can also easily draw and make changes. So if I did something like this, okay, again, every corner is a carbon, okay, and even at the end here, you have a single carbon. So there's 1, 2, 3, 4, 5 carbons. But these are single bonds. This is not a single bond. What I've drawn here is a double bond. Okay. So because you have 5 carbons, the prefix is pent, but because of the double bond, you have to change the ending from ane to ene. Okay. So if I wanted to draw out pentyne, okay, a Y-N-E ending means that I'm looking at an alkyne. And alkynes have triple bonds. So if I'm using the zigzag method to show that, okay, I would have 3 lines to show a triple bond. And then I put in my carbons. Okay, so again, we have 1, 2, 3, 4, 5 carbons. So this is a pent. Oh, wow. You know it's a pent. Okay, so we have pent. And then because of this triple bond, we basically have the ending YNE for pentyne. Okay. You can show everything that I have here with your condensed structural formulas as well as your expanded formulas. The main take-home message is you need to count the number of carbons, okay, that are consecutively bonded together to find the parent chain. That will give you the prefix. You look to see if there are single bonds, double bonds, or triple bonds to figure out the ending of the paired chain. Okay, and that will give you either your anes, enes, or ines. So I hope this has been helpful. Okay, in the next video, we'll take it up another level and show you how to name branched hydrocarbons. See you guys soon.